Yeah, the recording of this video has started. So today I'm going to talk about the exact and linear ordinary differential equations. So the videos on these both topics have already been available, but here I will discuss live with you for these. So first of all, let's talk about the exact ordinary differential equation. Okay, exact. So exact equation is that format. Okay, so there is a function m times dx, and there is another function n times dy equal to 0, where m and n are functions in x and y respectively. So this equation, this type of equation will be called as exact if the partial derivative of m with respect to y will be equal to the partial derivative of this function n with respect to x. Okay, and once this equation is exact, then you can solve it by adopting certain method. So let me show you with the help of the one example. So example, let's take this equation cosine of x plus y dx plus 3y square plus 2y plus cosine of x plus y times dy is equal to 0. So this is the equation in this format, okay? And in this case, if you can compare this equation with this format, so this is the function m, this is the function n. So we have to determine whether this equation, this is an exact equation or not. So for this, we can take the partial derivative of m with respect to y. We can see that m is a function of both x and y. So we'll take the partial derivative of m with respect to y. So it will be cosine. So cosine derivative is minus sine x plus y. And from the chain rule, x plus y. So it is x will be considered as constant in this case. So the derivative of x in this case will be 0 because we are taking the derivative with respect to y. And then for the derivative of y will be considered as 1. Okay. So 0 plus 1. So that will be minus sine x plus y. So minus sine x plus y. Okay, so next we will check the partial derivative of n with respect to x. So partial derivative of n with respect to x. So we will now need to derivate with respect to x. So 3y square, because y will be in this case considered as constant, it will be 0. 2y, so it will be also 0. And then for cosine of x plus y, so it will be minus sine x plus y, and which is same as before, so it will be 0 plus 1. So it will be minus sine x plus y. So now we can see that partial m over partial y and partial n over partial x are both equal to minus sine x plus y. So we will say that this equation is exact. Okay, this equation is exact. So once we see that the equation is exact, we can find the solution of that equation. So for let's assume that the solution is represented by capital F. Okay. Okay. Well, at this moment we don't know what is that solution. So the property of that solution will be that the partial derivative of that solution with respect to x will be equal to this m function. Okay, that will be equal to this m function, cosine of x plus y. So this will be the property of the solution when the equation is exact. So in this case, from here, because this is the partial derivative of f with respect to x, so we need to find x. So then we can integrate it with respect to x. Okay. So integration of cosine is sine x plus y, okay? And then from the chain rule, it will be x plus y, so it will be uh, x plus y. So for x, it will be 1. For x, it will be 1. For y, it will be 0. And then there will be a constant, okay? So normally we represent the constant by C, okay? In this case, that constant is a numerical value or some other non-changing value. But here in this case of partial integration, the constant can be a function in terms of the other variable y. So in this case, we are integrating with respect to x. So the constant can be a variable in terms of y. So that variable y will be constant with respect to x, okay? So instead of a constant, we can take it as a derivative of a function of y. So function, now we already know this function, which is the solution, but in this case, we don't know about what is gy. So to determine gy, what we do is we will take the partial derivative of this f with respect to y, and then it will become cosine of x plus y, okay? Cosine of x plus y into derivative of x will be 0 and derivative of y will be 1, okay? For the chain rule. And then the derivative of g of y will be represented by g prime of y, okay? So when we represent it like this, so it was, by simplification, it will be cosine of x plus y plus g prime of y. By definition, this partial derivative of f with respect to y should be equal to this n function, okay? This n function. So what is that n function? N function is this. So by definition, it should be equal to n function. So 3y square plus 2y plus cosine of x plus y. Okay. So this should be equal to n. So now what we can see that if we compare these two expressions, so we see that cosine of x1 y is equal to cosine of x plus y, so it is fine. So this means that the other values should be, these two values should be equal to g prime of y. So g prime of y will be equal to 3y square plus 2y. So this is a function with only one variable y. So we can integrate it to find the value of g of y. So g of y will be equal to, so we can integrate it with respect to y. So it will be 3y cube, 2 plus 1, that means, and then divided by 3. Because it is a polynomial, so for polynomial, power 1 plus n plus 1 over n plus 1. And then it will be 2y square over 2, okay? We will not add any constant because that is not needed at this moment. So y cube plus y square. So we've found the value of g of y. So now we know that our solution is f. Okay? Solution is f. So what is that solution? Sine of x plus y, sine of x plus y, and plus g of y. For g of y, we have already found y cube plus y square. So this is the solution function. And then at the end, we will say that it will be equal to a constant value. So this will be the solution of the given ordinary differential equation, okay? And you can see that this is not an explicit solution, this is an implicit solution, okay? It is not an explicit because we are not representing it with, in terms of y is equal to something. So it is an implicit solution, okay? So with this, we have found the solution. We can easily check whether that solution is correct or not using the partial differentiation. So what is the partial differentiation? So if, for example, if we say that if there is a function of f, if there is a function, if there is a function z, which is a function of x and y, such as this function over here, this is a function of x and y. Its partial is its derivative with respect to both x and y, which we can represent by like z prime. Z prime can be represented by partial f over partial x into dx plus partial f over partial y into dy. So this is the simple formula. So using this formula, we can integrate it and then we can verify our solution as well. So first we will integrate it with respect to x. Okay, so it will be cosine of x plus y, and from the chain rule, it will be cosine x will be 1, y will be 0, so it will remain just cosine of x plus y. And for y cube plus y square, it will be 0, so it will be dx, then dx. So partial f over partial x is simply cosine of x plus y, and then dx. And then second, we will differentiate it with respect to y. So it will be cosine of x plus y. From the chain rule, it will be 0 plus 1, so it will remain cosine x plus y. For y cube, it will be 3y square. For y square, it will be 2y times dy, and then that will be equal to 0 because the derivative of a constant value is equal to 0. So you can see that we get the same equation by this partial differentiation equation, partial differentiation. So you can see that our original equation was this 3y square plus 2y plus cosine of x plus y. So we got the same equation. So in this case, we have already we have verified it. Okay, we have verified this solution. So is it clear, this solution? If you have any question, maybe you can ask now. Okay, so next, this was the exact equation. So next, take another example. In this case, I'm using the non-exact equation. Okay, so let's take a very simple equation, minus y dx plus x dy, or maybe I can use some other little bit complicated. So let's try this one, another example. In this case, the equation will be non-exact. Okay, non-exact. So when the equation is non-exact, let's take the example, e power x plus y e power y dx plus x e power y minus 1 dy is equal to 0. And let's take that as an initial value problem, y0 is equal to minus 1. That means when x is equal to 0, the value of y is equal to minus 1. So let's first check whether this is an exact equation or not. So this is m, this is n. So take the partial derivative of m with respect to y. So it will be e power x plus y. From the chain rule, it will be 0 plus 1. So that will be 1. Now take the partial derivative of this. It will be y times e power y, okay, and then plus e power y into derivative of y is 1. So This is partial m over partial y. And what is the value of partial n over partial x? It will be, now we are taking it with respect to x, so it will be x e power y and plus y, e power y into x, that means 1, that will be 1. And minus 1, the derivative of 1 will be 0. So in this case, we can see that both of these terms are not equal. So this means that this equation is not exact. Okay. So in this case, situation, if we want to make this equation as exact, so there is a procedure. So for making this procedure, for this procedure, we need to find a function mu, which we will multiply with this original equation, and then that equation will become an exact equation. So how we can find this mu? So this mu can be found by one of the two approaches. So one of the approach says that we take we take a function. We take a function. Sorry. So one of the approach is that we take the exponent. We take the exponent of the function p, which is a function of in terms of x, and take its derivative. Okay. And what is this p function? That I will explain later. This is another approach. Or if it does not work, then we can take also another approach, exponent as a function of q into dy. So q in this case will be a function in y. Okay, dy. So we can find either way of this. So what is p? So p is basically a function that will be equal to 1 over n times partial m over partial y minus partial n over partial x. Okay. So what will be this p function? 1 over n, n is equal to, sorry, what n is equal to this x e power y minus 1, x e power y minus 1. And then what is partial m over partial y? Partial m over partial y is this e power x plus y plus y e power y plus e power y. Then you have minus x e power y and minus e power y. So in this case, this looks like a little bit complicated solution. Okay, complicated expression. Okay. So if, for example, e power y will cancel with e power y, and then what we left is with this equation. So x e power y, this will be x e power y minus 1. So maybe this seems to be a very complicated solution. Maybe we can try the q function. Okay. So in this case, q will be equal to 1 over m. The value of q will be equal to 1 over n. That will be equal to partial n over partial x minus partial n over, sorry, partial m over partial y. Okay. So in this case, it will be 1 over m. M will be, m is equal to this e power x plus y e power y. Okay. So, and then partial n over partial x will be that will be equal to x e power y plus e power y minus e power x plus y minus y e power y and minus e power y. So I think we need to simplify it from here. E power y will cancel out with e power y. And then what is left is over here is equal to, this is e power y. Okay, so e power y we can take as common from here. E power y. And then what is left over here is x minus e power x and minus y. Okay. And then from the denominator, it will be e power y into e power x plus y. So e power y cancels with e power y. So we are left with this expression, x minus e power x minus y over e power x plus y. However, this expression is also still complicated. Okay, just hold on a second. I think I need to, I have made some mistake over here. Okay, so I can just hold on a second.